What is up, y'all? It's Medicine with AUNO. So today we are going to talk about the lymphatic system. So here's a lymph node right here. But the lymphatic system has all these parts and components, and you can see it stretches throughout the body with lymph nodes and vessels and ducts and trunks and organs and all kinds of things. So we're going to talk about several things here about the lymphatic system. So first off, what are the components of our lymphatic system? So we have lymphocytes, which are made in bone marrow and mature in the thymus. Here's a lymphocyte here, and these are different types of lymphocytes. We have bone marrow. These make our lymphocytes, so this is part of the lymphatic system. You have the stem cell, and then you can make a white blood cell. Lymphocyte is one type. You have our thymus, which is a gland, which takes part in education of lymphocytes, memory cells via exposure to pathogens and antigens. The thymus is larger in young children and will shrink with age. This here, MALT, is diffuse lymphatic tissue, which is called mucosa-associated lymphoid tissue, usually found in the GI system. And we can see that here. I believe this is probably part of the small intestine, but I'm not sure. But you can see our lamina propria contains MALT tissue, or this lymphoid tissue. The lymphatic nodules, they just hang out by themselves. I don't know what they do. I don't really care what they do. But anyways, lymph nodes. This is the lymph node, y'all. So you have your afferent lymphatic vessels where the lymph enters into the lymph node. And then the lymph fluid will enter out through the efferent lymphatic vessel. And you can go to like the duct and, back to the venous system. I'm not sure what all this means, so we're just going to ignore it. Spleen and tonsils, these are lymph organs. So we see our spleen over here, which plays an important role within the lymphatic system, as well as, but we can live without the spleen, interestingly. But also tonsils, and we can have hypertrophy of several tonsils. We see most common, like the oropharyngeal tonsils. I think that's what they are, with strep throat, but enlarged tonsils. And here are adenoids enlarged here. We also have lingual tonsils, which are at the base of the tongue. And these can actually become hypertrophic as well, which rarely, but they can require surgical removal because if they get too swollen, they can mess with the airway and stuff, and epiglottis right here. So these lymphatics are not found in the brain or bone, so that's important for teeth. So not CNS or anything like that. Everywhere else you have lymphocytes connected through lymphatic vessels, right? So that might supposed to say lymph nodes. I'm not sure, y'all. But that's basically our components, right? So we have our lymphocytes, bone marrow, thymus, mucosa-associated lymphoid tissue in the GI tract, lymph nodes, lymph nodules, spleen, and tonsils. So that's our components of the lymphatic system. So what's the basic function of the lymphatic system and its role in the spread of disease? So the lymphatic system protects the body using the immune system so that it can reject foreign invaders. And it defends the body by producing our lymphocytes in the bone marrow. Instrumental in spread of cancer as well, metastases or infection spread. Absorption and transportation of fats from small intestine to circulation, that's that MALT tissue, lymphoid tissue in the intestines, and absorb and return tissue fluid, interstitial fluid to the vascular system. All right. So more than 3 liters of lymph fluid exits the bloodstream daily, and this is pushed out of leaky capillaries, which we'll look at. And this can't be taken back by the capillaries, which holds 5 to 6 liters of volume daily. Half of the blood volume will circulate through interstitial and lymph fluid daily. Overflow system is what we can call that, kind of just takes the excess out. Drainage of surplus lymph fluid. So leak plasma proteins and cellular debris. That's part of the function. It drains these things. And if it were to accumulate in extracellular space, you would have reverse osmosis, which would allow fluid to enter the region, resulting in edema, which you can see in patients who have had lymph node dissection and they get lymphedema. So this sounds like it's going to explode on me. Coca-Cola at midnight, y'all. Cheers. Gotta keep me awake. All right, so increased blood pressure in capillaries can also increase lymphatic pushing out, lymph fluid pushing out, lymph production. And also decreased concentration of plasma proteins like in malnutrition will also increase lymph production. Proteins in interstitial spaces can only return to the blood via lymph, so they have to go through the lymph, these proteins. So they return lost fluid, extracellular fluid, cellular debris, pathogens, and proteins. Lymph vessels use pumps to send lymph distally, and these pumps include skeletal muscle pumps and the respiratory pump, and it increases pressure, and these valves close, and they don't reflux the lymph fluid. Next slide, y'all. So here's the flow of lymph from extracellular interstitial spaces to the circulatory system. So we start off with our heart. We pump the blood out. Goes through the arteries to smaller arteries branching off in the capillary bed, which is in this picture here. And then we have leaky capillaries, right? So they will leak some fluid out into the interstitial space, and these lymphatic capillaries in green will pick up this fluid through these little flap-like mini valves, pick up the fluid and send it back through the lymphatic system. And again, this is like 3 liters a day. But the rest of this fluid will continue through like the bloodstream capillaries into the venules back to the veins, and inferior vena cava or superior vena cava. So some of it's going to just go through, some of it's going to leak out and go through the lymph system. Picked up by lymphatic capillaries, lymphatic vessels, right? It goes to lymphatic collecting vessels, valves, and then the lymph nodes will pass through those, get filtered out, and lymph nodules and larger lymph trunks, and lymph ducts, lymphatic ducts, and then the venous system in the heart. So we're going to look at that a little closer. But yeah, lymph capillaries, vessels, nodes, trunks, ducts. So lymph vessels, they always flow superficial to deep and drain superficial to deep. So they drain through lymph nodes. So we can see anterior medial thigh, and we can see the great saphenous vein here, superficial lymphatic vessels. So you're going to drain first to the superficial inguinal nodes right here, then drain into the deep inguinal nodes, right? All right. So lastly, differentiate areas drained by each of the terminal lymphatic ducts. So we are going to first talk about the trunks first, and then we'll get to the ducts. So we have some major lymphatic trunks. We have the left lumbar trunk, the right lumbar trunk, and the intestinal trunk. So obviously, intestinal trunk drains our intestines. Our left and right lumbar trunks drain our lower limb. This fluid will accumulate in the cisterna chyli, and then we'll take it up from there into the thoracic duct. We also have the bronchomediastinal trunks up here and up here, left and right. And we also have the, that's going to drain thoracic viscera. We also have right and left subclavian trunk to drain upper limbs, right subclavian trunk, left superior trunk. And then we also have right and left jugular trunks, right? And these are going to drain our head and neck. So these trunks are going to merge into 2 major lymphatic ducts. So the first one we're talking about is the thoracic duct. So this is right here, right? And that's going to basically take all the lymph from our cisterna chyli, right here. Cistern, it just collects all this junk from down here in these 3 trunks. And it's going to take all that. It's going to take it up, run posterior to the internal jugular vein, the brachiocephalic vein, and it's going to run behind the left subclavian vein. And it's going to be more on the left side of the body. And then it's going to merge with the junction of the left subclavian and internal jugular right here to drain into brachiocephalic vein on the left and go into the superior vena cava and heart. So that is our thoracic duct. Drains 3/4 of our body, right? Drains left side, drains below the diaphragm, I believe. So it's draining lower limb. And we know that because, remember, it's going to drain our intestines. It's going to drain left lumbar, right lumbar. So right and left lower limb. So it makes sense. It's draining all this. But it's not going to drain our right thorax or our right arm or our head on the right or neck on the right. But everything else, see this left jugular trunk and this left subclavian trunk, and the left bronchomediastinal trunk, all are going to drain into the thoracic duct. They're all going to drain into here. So all this head, neck, and left arm are draining into this one duct. So that's why all this is drained ultimately by this duct. And over on the other side, it's the same thing. You have the right bronchomediastinal trunk, right subclavian trunk, and the right jugular trunk. And you can see how these all will flow into this right lymphatic duct. So they all flow in and merge. This picture here, well, I guess they all still are merging right here. So it's bilateral, it looks the same. So it's the larger of the two ducts. It doesn't collect this right side. T12 to root of neck is where this thing runs. So down at T12 to root of neck. Can be the first sign of intra-abdominal cancers, breast cancers, I believe some other cancers. But anyways, you'll have this enlarged supraclavicular lymph node on the left, which is right here. Why? Because basically all your lymph is emptying through this region. So like you can get, this can develop cancer cells in the lymph node up here. So your thoracic duct empties into the left brachiocephalic vein. So and if blocked, our lymph can quickly fill the pleural cavity as well. So if this duct is blocked, lymph can fill the pleural cavity. And you've heard of pneumothorax, air in the pleural cavity, or air in the thorax. Chylothorax is lymph, I guess, in there. So yeah, I still am confused on why this supraclavicular lymph node would be large. Someone go comment down in my comment section why this would occur, because I understand it's draining all this stuff. So you can have an intestinal cancer because it's draining through the intestinal trunk. You could have a, I guess, just various cancers that would drain. And but if you have cancer going through the thoracic duct, I didn't think this would pass through lymph nodes because lymphatic vessels pass through lymph nodes. So I don't know how this connects to the supraclavicular lymph node to basically deposit cancer in there. So someone go let me know. So let's talk about the other duct, right lymphatic duct. This is the smaller of the two ducts. It's right here. And this is going to be joining at the similar junction, internal jugular vein, right here, and the right subclavian vein, right here, and it's going to form the junction of the right bronchomediastinal, forms from the junction of the right bronchomediastinal trunk, right jugular trunk, and the right subclavian trunk. So that's the junction of those, and then the right lymphatic duct, all these trunks will drain into, which will drain into the junction of the internal jugular and the right subclavian vein, which will go into the right brachiocephalic vein, into the superior vena cava. So, thoracic duct is going to drain the left half of our head. This is thoracic duct. Left half of the head, neck, and thorax, along with the left upper extremity, and drains the body below the diaphragm, including abdomen and lower extremities. Now the right lymphatic duct, okay, so here's an exception. This is important to know. So it drains right head, right neck, upper extremity on the right side, and right thorax. But it also will drain the inferior lobe of the left lung. So the inferior lobe of the left lung, which is so precise, inferior. So will be drained by the right lymphatic duct. And can we see a picture of that? No, so I don't know why that happens. But anyways, that's something to note. And yeah, that's the end of this video, y'all. This is just showing these merger of the trunks into thoracic duct, which drains into here. And that's all, y'all. So thanks for watching the video. Best of luck to everyone out there. Let's keep going. Don't quit. I'm out.